In this video, you will learn how to divide real numbers as well as some properties of dividing real numbers. When you divide, you are basically multiplying, and you're multiplying by the reciprocal. So for example, if you were to divide by 2, that is the same thing as multiplying by 1 over 2. So if you had 8 divided by 2, that would equal 4. And then 8 times 1 over 2 would also equal 4. So division is a form of multiplication. If you were to divide by 3, that is the same as multiplying by 1 over 3. So for example, if you had 9 divided by 3, that would equal 3. And 9 times 1 over 3 would also equal 3. So division is a form of multiplication. More specifically, your definition of division would be that for every real number a and every non-zero real number b, the quotient a divided by b, or a over b, is defined by a divided by b equals a times 1 over b. So that's the complicated math definition. But in other words, to divide by a number, you simply multiply by its reciprocal. All right, any sort of division problem can be expressed as a multiplication problem. So for example, if you had 27 over 3, all right, 27 divided by 3, you can write that as a fraction or with a division sign, same thing. And instead of dividing by 3, I can multiply by 1 over 3. And either way, 27 over 3 would equal 9. All right, if you had 27 divided by negative 3, you could write it as a fraction or as you see here with the division sign. And dividing by negative 3 is the same thing as multiplying by 1 over negative 3. And either way, my answer is going to be negative 9. All right, a positive 27 and then divided by a negative 3 would be a negative 9. All right, so if the signs are different, it's going to be a negative number. If we had the negative on the top, so negative 27 divided by positive 3, that's the same thing as multiplying by 1 over 3, which would also equal negative 9. So the signs are different, negative and positive, so when I divide, it's going to be a negative number. And then here we see negative 27 divided by negative 3. All right, when I divide by negative 3, that is the same thing as multiplying by 1 over negative 3, or negative 1 over 3, same thing. So when I multiply, or when I divide, it's going to be negative with a negative, which makes a positive, and then 27 divided by 3 is going to be 9. So my rules for division are the same as for multiplication. So if the two numbers have the same sign, then the answer is positive. And then if two numbers have opposite signs, then the answer is going to be negative. So for example, here we have negative 12 divided by negative 10 over 3. All right, first off, the division we can think of as multiplying by the reciprocal. So we can think of this as multiplying, and then instead of negative 10 over 3, we would have negative 3 over 10. We switch the top and the bottom. All right, so when I multiply, I can do this the long way, or I can do a shortcut way. The longer way is we would multiply the tops together. So we'd have 12 times 3, which would be 36. And then the bottom, we'd have 1 times 10, which is 10. And the sign, we have negative times negative, which would be a positive. So we have 36 over 10, which we can then reduce, divide the top and the bottom by 2. That would give me 18 over 5. And if I wanted to, I could write that as a mixed number, and you get 3 and then remainder of 3. So 3 and 3 over 5. All right, so that's the longer way, where I multiply first and then I reduce after. But it's maybe quicker to reduce first and then multiply. So when I multiply these together, anything in the numerators I can reduce with anything in the denominators. So the 12 and the 10, even though they're different fractions, I can actually reduce those two things. So divide 12 by 2 to get 6, divide 10 by 2 to get 5. So I reduce the top and the bottom, and then I multiply 6 times 3 to get 18, and then 1 times 5 to get 5, and then the sign once again would be positive. Here is another example. This one looks complicated because we have two fraction bars. But remember, the fraction bar simply means divide. So what I have here is -4, and then this fraction bar means divide. So I'm dividing by what? I'm dividing by this -1/4. So I can think of this as -4 divided by -1/4. When I divide, that is the same thing as multiplying by the reciprocal. So instead of dividing, I'd be multiplying, and instead of -1/4, it'd be -4/1. Alright, so I have -4 times -4/1. -4/1 is the same thing as -4, so we don't need the 1 down here. -4 times the -4, we have negative times negative, which is positive. 4 times 4 gives me 16. So my solution would be a positive 16. Next we have 45x divided by -9. So here we have a variable thrown in, but the process is still the same. We can look at the number part, the 45 and -9. We can reduce by dividing both by 9. When I do that, I have 5 on the top and then a -1 on the bottom. So I have 5x over -1, which you can think of that as just -5x/1 or just -5x. That is the same thing. So my solution is -5x. Next I have w/12 times 12. And there's different ways you can think of this. I think the easiest way is to think of this as w/12 times and then 12/1. So if you have it this way, you can multiply first and then reduce after, or reduce first and then multiply. Either is fine. I personally find that reducing first is easier. So I can reduce anything on the top with anything in the bottom. So I'd have 12 divided by 12. You get 1/1. So I'm left with w times 1, which is w, over 1 times 1, which is 1. So my answer would be simply w. Here I have two different questions to make you think a little bit. So my first question to you is, why can you never divide by 0? And maybe you never thought about this before, but you can't. You cannot divide by 0. But why can you not? So the answer to this is because division is the same thing as multiplying by the reciprocal. Alright, so if I divide by 0, that means that I'm multiplying by the reciprocal of 0. But 0 has no reciprocal. So therefore, dividing by 0 would have no solution. And we'd say that anything divided by 0 is undefined. So if you had like 5 divided by 0, the answer to that is undefined. There is no solution. Alright, so then question 2, can you divide 0 by a number other than 0? So could I have something like 0 divided by 5? And the answer would be yes, because division is the same thing as multiplying by the reciprocal. So this would be the same thing as 0 times, so instead of dividing by 5, I'd be multiplying by 1/5. And we know that anything times 0 is going to be 0. So yes, you can for that reason. So the way to remember which one is undefined and which one is 0, if the 0 is underneath, it is undefined. Notice the words sound the same. Underneath, undefined. So that would be that answer. And then 0 on the top would just be 0. Okay, I have two more questions with division. So the next question is division commutative? Commutative meaning, does the order matter in which I divide? So for multiplication, multiplication is commutative because 4 times 5 is the same thing as 5 times 4. The order does not matter. But with division, division is not commutative because 6 divided by 2 is not the same thing as 2 divided by 6. All right, 6 divided by 2 is 3. 2 divided by 6 would be 1 over 3, or 0.3 repeating. Next question, is division associative? Well, associative, remember, means how I group things together. So for multiplication, it was associative because if I had 2 times 3 times 4, it doesn't matter if I do 2 times 3 first and then multiply by 4. That would give me 24, 6 times 4. Or if I do the 3 times 4 first and then multiply by 2 after, which would be 2 times 12, both of which would give me 24. With division, division would not be associative because if I had 18 divided by 3 divided by 2, if I do 18 divided by 3 first, like you see right here, okay, that gives me 6. 6 divided by 2 is 3. Okay, if I chose to do the 3 divided by 2 first, that would be 18 divided by 3 over 2. Means I am taking 18 times 2 over 3, which would be 36 over 3, which is 12. So bottom line, the answers are different. So with division, division is not associative. And one last thing with division, if you have a fraction, so here we see a fraction and the numerator has a plus or a minus sign. What I can do is I can break up the fraction. So I can break it up so I have a over c plus b over c. I can create two fractions with this. And same thing with subtraction. If I had a minus b over c, all right, I can break it apart into two fractions where we have a over c and minus the b over c. So for example, let's say we had 8 plus 12 over 4. All right, I can break this up as 8 over 4 plus 12 over 4, which would give me, either way, would give me 5 as my answer. Right, so looking here on the left side, 8 plus 12 is 20. 20 over 4 is 5. On this right side over here, if I split it up, 8 over 4 is 2, and 12 over 4 is 3, and 2 plus 3 would equal 5. So we verified that this does work. I can separate. And we'll do one with subtraction. If we had 8 minus 12 over 4, that is the same thing as 8 over 4 minus 12 over 4. I can split it up into two fractions. So if I look at this one way of doing it on the left side, 8 minus 12 over 4, 8 minus 12 is negative 4. Negative 4 divided by positive 4 would be a negative 1. On the right side, 8 over 4 is 2, and then 12 over 4 is 3, so I have 2 minus 3, which would also equal negative 1. So we have verified that this property is true. And as we progress in our study of algebra, this property will be important for various different things, and this is a sticking point for many students. So make sure you understand this concept as we move forward.